Hey guys, Mr. Gran here, and this is the 11.5 lesson on graphs of data sets. All right, so the first thing that we're going to talk about are, the first type of graph is going to be dot plots. So a few questions. This is a picture of a dot plot, and what it shows is that each of these dots represents one data point of the value that's underneath it. So 2 data points had 0, 3 data points had 1, 5 had 2, 3 had 3, and 2 had 4. So number of brothers and sisters, that means that 4 people had, or 2 people had 4 brothers, 3 people had 3 brothers and sisters, 5 people had 2 brothers and sisters, and so on. All right, so what does the dot plot tell us? It tells us the number of data points with specific values, right? So now where could this be useful to create a data plot? I would say that this is when we want to know how many points have a specific value. When we're working with smaller data sets with repeated values, and we want to know how many of each specific kind there are, and we want a visual representation to it. Now, some limitations of this. These are not going to be very useful if you have wide ranges of values. If you have large numbers of data points, like if there was 100 twos on this one, right? Like it has to be a small enough number of values that you can count the dots or at least see the difference between them. And it also isn't going to make a lot of sense if there aren't a lot of repeating values. So like with the Snapchat scores one, that wouldn't be a good one for this. Okay, so creating a dot plot in Geogebra. So we're going to use the same Snapchat score stuff as last time. So if you have that still, if you don't, go to the our data Google Sheet that is linked on the Canvas page, and go ahead and highlight the data, right? Copy it, edit, copy, or Command C. Then go to Geogebra and paste it in there so that it looks like this. And now I'm going to highlight the boys, one variable analysis. And like we did yesterday, it gives us a histogram to start with. But if we click the little arrow next to histogram here, we can change it to a dot plot. And so this is where, the dot plot of the boys versus girls stuff doesn't really make a lot of sense for this one, but that's how you would do it, is you would do the same thing, one variable analysis, and then click dot plot. Okay. So there's the other things. So choose dot plot, and there's your dot plot. Okay, analyzing dot plot. So looking at this one, we want to answer a few questions. Now remember that each of these dots represents one point of data in for number of people in the household, right? So this means that for the chunk of the survey we're looking at, that 5 people lived in a household with three members. It looks like 6 people lived in a household with 4, 2 people lived in a household with 5, 1 with 6, 1 with 7, and 1 with 8. All right, so how many people answered this survey? Well, if I add up all of these dots, that's the total number of people that answered the survey, and that is a total of 16 dots. How many people are in the largest household? So the largest household is 8, right? This is our maximum value over here. This represents one person who answered with a value of 8. What is the most common household size? Well, according to this data, it would be the one with the largest number of dots, so 4. So there were 6 people who answered that they lived in a household of 4 people. So 4 is the most common household size. How many more students have 4 people in their household than 3 people, or than 5 people in their household, excuse me. So there were 6 people who answered that they lived in a household of 4, and 2 who answered that they lived in a household of 5. So the difference there are 4 more people that live in that household of 4 than people who live in a household of 5. And then what is the median size of the household? Now, I know that I had 16 total numbers here, right? I have 16 total values. So the middle of that would be 8, right? And it would actually be between 8 and 9 because it's an even number. So if I start counting up the dots, right? 1, 2, 3, 4, 5, 6, 7, 8. The 8th value, if these were in numerical order, would be 4, and the 9th value would also be 4. So the median here is also 4. All right, so histograms. Histograms are often mistakenly called bar graphs or bar charts by students, but they actually are not. They kind of look like them, but they are a little bit different. So what a histogram will tell us, so looking at this one, we've got tree heights. On the vertical axis, this is our frequency. On the horizontal axis, these are our data intervals. And so according to this, the height of this bar in the histogram is going to tell me how many trees were between 100 and 150 centimeters. And then this bar is going to tell me, okay, there's about 30 trees that were between 150 and 200 centimeters, and so on. All right, so what a histogram tells us is the number of data points within a specific interval. So it doesn't tell us that, how many are exactly 155. It tells us in this little range between 150 and 200. All right, so when could this be useful? These are typically useful if you're looking at large sets of data with large ranges and not a lot of repeating values, right? A dot plot for something like this might look a lot like a flat line, kind of like the one that we did for the Snapchat scores. And so with this, if it doesn't have a lot of repeating values, I don't necessarily want to know how many trees are exactly 155 centimeters and exactly 156 centimeters. That might not make as much sense in this case as wondering how many trees are between 150 and 200. And this gives us a look at how the data is distributed in terms of these regular intervals, where I don't want to get super focused on specific values. All right, so some of the limitations, though, are that it doesn't show you the specific data points. If for some reason I wanted to know how many were exactly at 155, this does not tell me that. All right, so our steps for creating a histogram, it's really the exact same thing as we did before. Go back to Geogebra, and we've got our stuff highlighted here. We literally could just click on on the little arrow next to dot plot and change it to histogram. But if we try to do this brand new, you would highlight the data that you want to look at, click the graph button, one variable analysis, and then change it to histogram. And so this, for that Snapchat data, I think is a lot more valuable to look at it this way, to show how many people are between 0 and 200,000, 200,000, 400,000, these intervals, rather than trying to look at, with the dot plot, how many people had exactly 0 and exactly, 100,000, exactly 1 million. That's not very useful for this particular set of data. All right, so some more steps, and these are in the PowerPoint and the notes. Okay, so then analyzing histograms. These are examples. So these are the results of Mr. Paulson's students guessing his age. So looking at this, how many people think that Mr. Paulson is between 36 and 39 years old? Well, I'd look at what bar represents the 36 to 39-year-old interval, and that is 5. The height of that, the count is 5, so there are 5 students. All right, what is the minimum age that someone guessed for Mr. Paulson's age? Well, we don't know exactly what the minimum is here. It could be 30, it could be 31, could be 32. So somewhere from the 30 to 32 range. Usually the The 33 would wind up in this bar. It would be like the left-hand side would be the minimum, right? So 36 would fit into this one, 39 would fit into this one, 42 would be here, and 45 would be here. All right, what is your guess looking at this now of the age of Mr. Paulson? So this would tell me, based off this, that 39, this value right in the middle, would be a pretty good guess. And knowing Mr. Paulson, it's not far off. It's a little young. He looks a little younger than he actually is. The guesses over here maybe would bring the average a little further this way to how old he actually is. He isn't over here, and he isn't over here, but he is a little bit right to the right of, he's somewhere in this one. All right, but looking at this, you would maybe guess 39. Okay, so now there's 16 total people who guessed how old guessed Mr. Paulson's age. From the histogram, do we know what each person's guess was? And the answer is no. We don't know what their guesses were. We know how many guessed in specific intervals. All right, now box and whisker plot. So the way a box and whisker plot works is this is looking at the minimum value, the quartile, the median, the third quartile, and the maximum. And so the minimum and the maximum, and I think the median are probably, we already probably are pretty familiar with, right? The very smallest value is right here. So there would be a number down here that this would represent. The very maximum would be up here, right? And so whatever the number is below that is your maximum value. The median, so what is your absolute minimum? Now, the way that we would read this is, if this is the median, that means that 1/2 of the values are to the right of the median, the half that are bigger than that middle value, and 1/2 are to the left, are less than that middle value. Now what this quartile, these two quartiles mean, these are kind of the medians between the minimum and the median. They're the middle there. So it's like if we took the lowest half of this data and then we cut that exactly in half, the quartile, the first quartile would be that center between, in that lower half. And if we did the same thing on the upper half, if we looked at all of the data that is, the numbers are greater than the median, so the top 50%, the top half of the data, and we took just that top half and we cut that in half, that's where this third quartile would be. And so what this tells us is that 25% of the data points are between the minimum and the first quartile. 25% are between the first quartile and the median. Between the median and the third quartile is another 25%, and then another 25% between the third and the maximum. And it sort of tells you how things are spread out in a little different way than a histogram. Another important value is this interquartile range. So that sort of tells you what values the middle 50% of the data is in between. So the stuff that is like 25% on one side and 25% on the other side of the median. So it's sort of like if you cut away the largest fourth and the smallest fourth, and you took that middle chunk, that would be your interquartile range, the distance between those 2 points. All right, so what this can tell us, this tells us how data is spread out in terms of quarters. It also tells us the minimum, the maximum, and the median values, as well as the quartile values. When would it be useful? This would be when analyzing how closely data is grouped, when we want to see a range of a data set divided into its 4 quarters. And some limitations: it doesn't show specific data point or as much detail of data distribution as a histogram or a dot plot. So yeah. All right, so making that, it's kind of the same thing. Let me flip over to my Geogebra tab. So if we highlight our data, we click, do one variable analysis. Oops, did I not actually, I didn't, the blue box looked like it was highlighted, but apparently it wasn't. I've been bamboozled. All right, so if it starts with a histogram, it's just as simple as switching it over to a box plot, right? And so now what this tells us, our minimum value is 0. Our median is about 200,000. And our maximum is actually over here at 1,000,000. But notice that the maximum has a little X on it. That means that this is what's called an outlier, which is like an extremely high, unusual value. Um, this value, look at the amount of space between this is the highest value and the second highest value is right here. So what this program will do is it will automatically take out, and this is a common thing with graphing software, that it automatically takes out these extreme values so that you can look at data that is a little more closely grouped, right? Like the vast majority of people are in this. And then there's this one outlier way over here that could really throw the data off quite a bit. So it can be useful to remove those outliers. Okay. So going back. So we did the box and whisker plot. All right, so now analyzing box and whisker plots. What is the median? So this is looking at the fruits and vegetables one, right? Median number. So if I look at the line in the middle here is the median. That looks like it's going to be 7, right? It's between 6 and 8, so it's going to be 7. Maximum number of fruits and vegetables in this group's fridge would be over here. I think that's, it stopped after 14, so that must be 15 right there is what I'm going to say. Minimum number, well, that's the one all the way to the left, and that is 2. And then the range. Now this one you do have to do a little bit of math. So the max is 15, the min is 2, so our range is 15 minus 2, which is 13. All right, a couple more. What is percentage of the households have less than 10 different fruits in their fridge? Ooh, this is actually, I have a mistake on here. It should be 75% because from 10 to 2, less than 10 different fruits, that would be this quartile, and this quartile. So each part here represents 25%. So this one is 25, this one's 25, this one's 25. Should be 75%, not 25. Whoops. And then what percentage of households have more than 7 different fruits? Well, if the median was 7, then if it's the median, then half are more than the median. So that would be 50%. So again, this 25% should be a 75%. All right, and I believe this is the last slide. So now looking at number of Instagram followers between male and female. Let's see. So the median number of Instagram followers for men, the median is right here. I think I said that was about 200. It's probably actually a little less than 200, right? Because if I go straight down from here, it's landing a little to the left of 200. The median number of Instagram followers for females, however, this one's a little easier to read because it's closer to the bottom, actually the horizontal axis. So if I go straight down, it's a little to the left of 400. So I guess 380 to 390, somewhere in that range was the median. So what conclusion can we draw from this information? Similar to the Snapchat scores, it seems like girls in FST have more Instagram followers, are probably more active on Instagram than boys. Now, what it doesn't tell you is why that is. It only states that that appears to be what's happening. All right, make sure that if you have any questions that you email your teachers, and have a great day.